Back to curves. We're trying to draw the derivative. We're doing this graphically. We're just looking at it. We're going to estimate it because we cannot determine the slope at every single point on here. It keeps changing. But we're going to do our best to figure this out. There is, on this particular graph, one point that we definitely know the slope. I know the slope of that one point for sure. It's because this vertex right here, the tangent line would be horizontal. And the slope of anything that's horizontal is 0. So right there where that vertex is, I'm going to make sure that my derivative, or my slope, has a value that's 0. Now, the slopes keep changing as I head to the right, but I do know something. Everything to the right of that vertex, everything over here, has a positive slope. So that means my derivative will have positive numbers. The derivative is your slope. If your derivative is a positive number, that means the slope of this original function is positive. The second thing I'll note is that the slopes do keep increasing. The slope may start off as 0 and then maybe 1/2 and 1, and then all of a sudden it's getting pretty steep pretty quick. So I know that my slopes here are going to be positive numbers and that they're going to get bigger. As I look to the left, take a look at that. Everything's going down from left to right. That means it has a negative slope. That means the derivative is going to be a negative number. And it's really steep here if we looked at the slope of the tangent line. But then as we go along, the tangent line isn't quite as steep as it was. So it gets closer and closer to 0. By the way, I want to point out that if you haven't noticed this before, the derivative of this quadratic function right here, the derivative happens to be a line. Interesting. Okay, let's take a look at a couple more. This one's always a problem. What about something like a square root function? Or maybe, we don't even know what the function is. That's probably a better example. But it looks something like that. So you have to try and evaluate, what do we know about the slope? Is the slope up there positive or negative? Are there points where it's 0? Are there points where the slope doesn't exist? Well, hopefully you determined every point on there. The slope's always positive. It's always going up. But where it starts off really pretty steep right here, the slope seems to be getting smaller and smaller and smaller. By the way, what is the slope right there at that point at 0, 0? That is the first point on a square root function. The derivative, or the slope of the tangent line. There is no slope of the tangent line there. It's an endpoint. So that point doesn't exist. What we have is something that is really, really steep. The slope's really steep here, but very quickly this slope gets smaller and smaller and smaller. Now, is that an exact value there? No, this is just my estimate, my guess of what this might look like. But isn't the slope getting closer and closer to 0? And my red line, which is the derivative of this function, my red line is getting closer to 0. Is my derivative, the red line, always positive? Yes, all of these are positive numbers. They're all above the x-axis. Does it start out steep and then get small? Yes. So this is just my estimate. Any of these graphs, if there is a bunch of curves, you're not going to be able to find the slope at every single point that exists. But you can get a good idea of what it might look like. I'm going to try and do this quick. Take a look at this, a random polynomial. There's 3 points where the slope is 0. Anywhere where you would have a horizontal tangent line, the slope 0. So for my derivative, at that maximum, and that maximum where the slope 0, and this minimum where the slope 0, my derivative will equal 0. The graph of the derivative I'm drawing will have a value of 0 because the slope on that original function is 0. Then, you know what? The only thing I know is these are all positive slopes, so I'm going to make those positive numbers. These are all negative slopes between that highest point, the max, and the lowest point, the min. So I'm going to make all those negative numbers. These are all positive again, and these are all negative. Do I know that's exactly what the